This is a tutorial screencast on the analysis of conformers by relative energy versus the dihedral angle of rotation. So the molecule that we're going to look at is butane. And we're going to look down the C2, C3 bond of butane. So I'm going to draw butane first like this. So here's just a regular flat drawing that you would normally see in lecture. And we're going to put our eyeball looking down the C2, C3 bond. And so for the 0 degree angle in the first box to the very left, what we're going to draw is our eyeball looking down C2, C3 with a Newman projection. So we're going to draw the front carbon. The methyl group is going to be down. And coming off that, we have 2 hydrogens. So in a Newman projection, we're always looking down a sigma bond. So in this case, C2, C3. So now if that particular drawing that we started with, the C4 carbon is going to be up. And so what we're actually drawing is the staggered conformation here. And the relationship between the 2 methyl groups is anti, so the dihedral angle is 180 degrees. So the relative energy of this staggered conformation, we're going to put a bullet point at 0 kilojoules per mole. The next thing we're going to do is a 60-degree rotation. So why don't we go ahead and we'll leave the back carbon stationary, and we're going to rotate the front carbon 60 degrees. So this methyl group is going to eclipse that hydrogen. This hydrogen is going to eclipse that methyl group, and these 2 hydrogens will then eclipse one another. So we're going to an eclipsed conformation here. So now we're drawing our rear carbon, which we've not moved at all. And we can see we have these different eclipsing interactions. So we have to account for what's the energy penalty for having these groups eclipsed. You can see we have 2 H methyl eclipsings, and we see over in this energy penalty to the side here, an H methyl eclipsing is 6 kilojoules per mole. So we have 6 plus another 6, and then the HH is 4. So we add those together, we're going to end up with 16 kilojoules per mole for this eclipsing conformation. So we go over, we're at 60 degrees now, that's what we rotated. We're going to put a dot. So I'll just put plus 16 here. So this conformation is 16 kilojoules per mole higher than the prior staggered conformation. Let's connect these dots with not a straight line, but say we were walking up or down a hill. So we're going to have some curvature to it. So the next thing we're going to do is another 60-degree rotation. And again, we're keeping the rear carbon steady, and we're moving the front carbon. So we're going to get back to this. So we have methyl. Now we draw in the rear carbon of the bond we're looking down. We have methyl, hydrogen,